Today let us discuss about one real world problem. So the major problem that an employer faces completing the given work in a stipulated time. If there are multiple employees in a particular organization, each employee may be good at doing a specific job. And if you are having multiple roles to play with, so you will choose the person in such a way that given person completes a specific role in a minimum amount of time, so that the total time is reduced. So this problem can be solved using many approaches like greedy technique or branch and bound. So today let us discuss how to solve this job assignment problem using branch and bound. So let me simplify this problem. So here, each worker has to do only one job, and each job has to be done only by one worker. So here, let's say someone called as Alice, she can do many problems, many works like baking, kneading the dough, baking the pizza, or making sauce, or delivering it. So this one person can do all the works, and same way, like all the other person can also do many works. So this makes the problem even harder because here we have so many combinations. So we need to choose the best combination and try to minimize the time that's consumed for the baking of pizza.
And that's a branch and bound comes in. So in this, by saying branch and bound, I mean that the branches can be the further options that come when you choose one option, and the bound is the upper and lower bound that you keep. So what I'm trying to say is that when you're trying to solve a problem like this, instead of visiting all the branches that are there and wasting your time on that, you can find the shortest path by first setting a lower bound. You can just first take a lower bound, which will be your estimated minimum, and then using that you will create a branch choosing one choice. You will take one choice, and that will lead to a branch of other certain choices. And when you will go into that and again apply the same principle and keep branching until you get the best possible solution. So what it effectively does is it helps you get to the most best solution without having to go through all the solutions. So yeah.
So now let's see the theoretical part, like how actually this problem is solved. So here we have taken example like these are jobs one, job two, job three, and job four, and these are A, B, C, D are peoples. So now we are like each people can do each job in different timing. For example, A can do job one in 9 minutes, and job two in 2 minutes, job three in 7 minutes, and so. So first, initially we are going to take the initial lower bound. So, Dinesh, can you say me like which are the initial lower bounds of all these jobs for each person?
First one A for 2.
Okay. Next is
Next for we can say 3 for B.
okay.
Next 1.
Okay.
And for next we can say 4.
4. So we add all these initial lower values and we take the initial lower bound as 10. From here, we need to like, for example, we can assign one job to one particular person. We can assign multiple job to the same person. So, we will take, if a person can do job 1 in 9 minutes. So we take for each jobs. So he can do job 1 in 9 minutes, 2 minutes, and 7 and 8. So next, the rule is we are not supposed to assign the job which is assigned to A for other people. So, for example, if you assigned job one for A, you are not supposed to assign job one for B, C, or D. You have to assign other three jobs. So, when we do that, we can see that for A1, we have assigned 9 initially, and the other we take the minimum values. So, likewise, Ashwin, we can see we have taken 4 jobs, and from here we calculate the 4 values. You can tell me which is the least job,
10.
least time.
10, right?
10. So if you see that, if we assign job 2 to person A, it takes the least amount of time. So we assign the job to person A. So by this we can't assign the job to any other people. We cancel this column. Next, if we see, we do the same thing for person B, but we can't assign job 2. We can assign only job 1, 3, and 4. So if you add all this, you can say, Indrajit, which is the lowest time? B13. B13. So for the B, we assign job 1, which takes 6 minutes for B. And by this, we can see 13 is the lowest, and job 1 is assigned for person B. So we can't assign it for person C or either D. Next, we can see person C has two possible values, that is job 3 and job 4. which is 1 and 8. We take both those values, and in this mega, can you tell me which is the least one?
30.
So 13. So the job 3 is assigned to person C. So next, finally, we have only job 4, which is assigned automatically to the last person. And from here, we can see the total amount of time, which is 20, compared to our initial lower bound. 20 is the actual time that is taken for every people to complete the entire jobs in less amount of time.
So after applying a bound and branches, we finally complete the assessment. For each persons, we assign each task. When the all tasks are covered, we can calculate the total time for assigning that assessment. That is the 20 minutes. For that is the our upper bound. That is also called that is the valid working time. If any timing that is lower than the 20 minutes, it is must be considered for a better working time.
So now coming to the conclusion that after we're checking all, if any other possibilities are there which can give a better result than the 20. So if any part reaches a higher time, then simply we can ignore it. So by viewing all the options, we can say that 20 is the optimal solution for this.
So, okay, let me summarize what you people have discussed so far. So, you were discussing about bound, right? So, why we calculate lower bound for this problem is the problem is about finding the least time in which the job can be completed. So, when it is a minimization problem, you go with the lower bound, unlike a zero and knapsack where we aim at maximizing the profit. So, if it is maximization problem, you will calculate the upper bound. So, if it is the lower bound indicates that the jobs cannot be completed below the value specified for the lower bound. So here the value I have calculated for lower bound is 10, which means the jobs cannot be completed before within 10 minutes. So the value will be greater than 10, obviously. And so as you have seen in the state stage 3 that Bharatwaj has drawn, only one branch is explored, other branches are left, right? So this is a major advantage of branch and bound technique over other techniques like greedy, because the greedy technique can also be used for solving a job assignment. But the major drawback is there all the possibilities will be explored, unlike branch and bound where only one possibility is explored. So the one having the minimum lower bound, that branch alone will be explored. So remaining other branches are marked as dead. So we will not explore the remaining branches. So hope you understood the concept.
Yes, ma'am. Thank you, ma'am.